In the vast darkness between the stars, something is moving, something that shouldn't be there, something that defies our understanding of the cosmos. In 2017, astronomers detected an object unlike any they had seen before. They named it 3I, Borisov I, confirmed interstellar comet. But 2 years later, another visitor arrived. This one was different. This one broke all the rules. This one was 3I ATLAS. When we first spotted 3I ATLAS, it appeared to be just another comet, a frozen relic from the outer reaches of our solar system, following its ancient orbit around the sun. But as astronomers tracked its trajectory, they realized something profound. This object wasn't from our solar system at all. It came from somewhere else, somewhere beyond, somewhere among the stars. Interstellar objects are cosmic messengers. They carry information about star systems we may never visit. They are time capsules from worlds unknown, and 3I Atlas is perhaps the strangest messenger we have ever encountered. Most comets are dirty snowballs, mixtures of ice, dust, and rock that formed in the cold outer regions of star systems. As they approach a star, the heat vaporizes their frozen materials, creating the characteristic tail that stretches across the sky. But 3I ATLAS defied this pattern. Its composition was unlike anything in our solar system. Its behavior suggested origins we couldn't explain. The first mystery was its trajectory. 3I ATLAS entered our solar system on a hyperbolic path, a clear signature of an interstellar origin. But unlike Oumuamua or Borisov, its approach angle suggested it came from the direction of the galactic center, not from the flat plane where most stars reside. This raised a profound question. Was 3I ATLAS ejected from a star system near the heart of our galaxy? Or had it been wandering the void between stars for millions, perhaps billions of years? Then came the chemical analysis. When astronomers pointed their spectrographs at 3I Atlas, they expected to see the typical signatures of water ice, carbon dioxide, and simple organic compounds. Instead, they found something unprecedented. The spectral lines revealed elements and molecules in proportions never before seen in any comet, asteroid, or planetary body. Most puzzling was the ratio of deuterium to hydrogen, an important cosmic fingerprint that tells us where an object formed. In 3I ATLAS, this ratio was off the charts. It suggested formation conditions unlike anything in our solar neighborhood. Perhaps it came from a region of space with different physical laws, or perhaps it formed around a different type of star altogether. As 3I ATLAS approached the sun, astronomers expected it to develop a tail as its ices sublimated in the increasing heat. But the comet remained stubbornly compact. No tail appeared. No coma developed. It was as if 3I Atlas was made of materials that didn't respond to heat the way normal cometary ices do. This led to a startling hypothesis. What if 3I Atlas wasn't a comet at all? What if it was something else entirely? The astronomical community began to consider possibilities that once seemed like science fiction. Could it be a fragment of an exoplanet destroyed in a distant cataclysm? Could it be composed of exotic matter formed under conditions we've never observed? Or could it be, as if you dared to suggest, an artifact of non-natural origin? The universe is vast beyond comprehension. In its immensity, the improbable becomes inevitable. As we peer deeper into the cosmos, we must prepare ourselves for discoveries that challenge not just what we know, but how we know it. 3I ATLAS reminds us that the universe is not only stranger than we imagine, but stranger than we can imagine. The strangeness of 3I ATLAS only deepened when astronomers began tracking its rotation. Most comets and asteroids tumble through space, rotating around their axes in predictable patterns. But 3I ATLAS rotated with impossible precision. Its period never varied, not by a second, not by a millisecond. It was as if the object was stabilized by some unknown force. This perfect rotation defied natural explanation. In the chaotic environment of space, where gravity, radiation pressure, and random collisions constantly alter the motion of small bodies, such stability should be impossible. Yet there it was, turning like a cosmic clock, keeping perfect time as it soared through our solar system. Then came the radio observations. The Green Bank Telescope in West Virginia detected something unexpected, a faint but distinct radio emission coming from 3I ATLAS. The signal was weak, barely distinguishable from background noise, but it was there. And it was structured, not the random static of natural processes, but a pattern with mathematical properties that suggested order. The signal wasn't a message in any conventional sense. There were no prime numbers, No binary sequences that could be arranged into images. Just a pattern that shouldn't exist naturally. A pattern that persisted even as the object rotated, as if emanating from its entire surface, rather than a specific point. When this data was published, the scientific community split into factions. The conservatives argued for natural explanations, perhaps an unusual interaction between the solar wind and the object's magnetic field, perhaps a new form of cosmic ray emission we hadn't observed before. The progressives suggested more radical possibilities that 3I Atlas might be a probe, a beacon, or a remnant of a technological civilization from another star. The debate raged in scientific journals and conferences, but while scientists argued, 3I Atlas continued its journey, indifferent to our confusion, carrying its mysteries deeper into our solar system. As it approached Mars, something even more inexplicable occurred. 3I Atlas changed course, not dramatically, just a slight deviation from its predicted trajectory, but enough to be measured, enough to be certain, and enough to violate everything we know about celestial mechanics. Objects in space follow paths determined by gravity. They can be deflected by collisions or outgassing, but 3I Atlas showed no signs of either. There was no visible jet of material that could have acted as a thruster, no nearby object massive enough to alter its course through gravitational influence. It simply changed direction, as if by its own volition. The deviation was small, just a fraction of a degree, but in the precision world of orbital mechanics, it was an earthquake. It was impossible. Yet the data from multiple observatories confirmed it. 3I Atlas had done the impossible. This course change brought it closer to Earth than originally predicted, close enough for our most powerful radar systems to ping it, to map its surface in unprecedented detail. The images revealed a surface unlike any comet or asteroid. No craters, no irregular terrain. Instead, a smoothness that approached geometric perfection, with patterns of light and dark that hinted at structure beneath. Some scientists began to whisper about the unwhisperable, that perhaps 3I Atlas was not just unusual, but artificial, not just a visitor from another star, but a visitor with purpose. The hypothesis was met with ridicule in some quarters, cautious interest in others, but as the evidence mounted, even the skeptics found themselves struggling to provide natural explanations. In the face of the truly unknown, human minds grasp for the familiar. We seek patterns, explanations, narratives that make sense of the senseless. But sometimes the universe presents us with mysteries that transcend our current understanding. In those moments, we stand at the frontier not just of knowledge, but of imagination itself. The final revelation came when 3I Atlas reached its closest approach to Earth. For a brief window, it passed through the shadow of our planet, experiencing an eclipse of the sun. In that darkness, it changed. Instruments across the globe recorded a surge of energy unlike anything seen before. Not radiation in any conventional sense, but a ripple in the quantum field itself, as if 3I Atlas was somehow interacting with the fundamental fabric of reality. This quantum signature lasted precisely 127 seconds. Then it vanished, leaving scientists with data they couldn't interpret and questions they couldn't answer. What had 3I Atlas done in Earth's shadow? What had it measured, or transmitted, or received? The mathematics suggested a level of quantum manipulation beyond our technological horizon, perhaps beyond our theoretical understanding. After this event, 3I Atlas accelerated, not gradually, as a comet might when heated by the sun, but instantly. One moment it was moving at its calculated velocity, the next it was 3% faster. No visible propulsion, no detectable energy source, just a change in state that violated our understanding of physics. As it receded from Earth, telescopes captured one final mystery. The surface of 3I Atlas began to shift. Patterns of light and dark rearranged themselves in sequences that mathematicians later determined were non-random. It was as if the object was reconfiguring itself, responding to some unseen command, or perhaps to what it had learned during its passage through our solar system. Then, as suddenly as it had appeared in our skies, 3I Atlas vanished from our instruments. Not because it moved beyond the range of our telescope's objects much farther, have been tracked successfully, but because it simply ceased to reflect light in ways our instruments could detect. It became invisible to us, though calculations suggest it continues its journey outward, carrying whatever secrets it gathered back to the stars from which it came. In the years since, scientists have pored over the data, searching for explanations that fit within our current understanding of physics. They have proposed exotic materials, unknown states of matter, even microscopic black holes embedded within the object's structure. But none of these hypotheses fully account for what we observed. Perhaps the most profound implication of 3I-ATLAS is not what it might be, but what it suggests about our place in the cosmos. If such an object can exist, whether natural or artificial, then our understanding of the universe is incomplete in fundamental ways. The laws of physics as we know them may be local phenomena, applicable in our corner of the galaxy, but not universally binding. Or perhaps 3I Atlas is evidence that we are not alone in our quest to understand the cosmos. Perhaps other minds, with other perspectives, have looked upon the same stars and drawn different conclusions. Perhaps they have discovered principles that elude us, technologies that seem like magic to our limited understanding. The story of 3I-ATLAS reminds us that the greatest discoveries often begin not with answers, but with better questions. It challenges us to expand our thinking beyond the boundaries of the known, to consider possibilities that seem impossible until they are proven inevitable. As we continue to scan the skies, we must remain open to the truly alien, not just rocks and ice from distant stars, but phenomena that challenge our most basic assumptions about reality itself. For in the vastness of space and time, the truly impossible may simply be waiting for us to develop the eyes to see it, and the minds to comprehend it. In the end, 3I-ATLAS may be the herald of a new era in our understanding of the cosmos, not because of what we learned from it, but because of what it showed us we have yet to learn.